Okay, so now we're going to consider this, which is not going to give us the problem that we had before where the only potential critical points occurred where they were forbidden, okay? Because the square root and you had the x's and y's in the denominator. So fx equals y equals 0. Geez, if y equals 0, right? Fy equals x equals 0 if x equals 0. So this is a critical point. Okay? Now test.
Oh, yeah, okay. Okay, I get my classes, I can get these in my class, but yeah. I'll see you guys tomorrow, you're good,
Test this, okay? Now one thing about this is always going to be negative because you're subtracting a square, right? Okay? So this is going to always draw down to the negatives where the saddle point occurs, okay? Turns out if this is less than 0, you've got a saddle point because this mixed partial pulls things away from what happens at the x and the y axes and screws it up, okay? If this is big enough compared to this product, you're done. Well, what's this product? fxx is 0, right? Because fxx is the x derivative of this, of fx. Okay? And that's the x derivative of y, which is 0, and vice versa over here, okay? Well, fxy equals fxy, right? And fx is y. You know, the y thing means partial with respect to y, right? I don't want to write y sub y, so I'll go to the partial sign. Anyhow, that equals 1, right? Not, note. Okay? Doesn't matter in which order you do the partials, it always works out, and after you've done half a dozen of them, you're convinced. Okay? And they're always easy. So I'll take a look at your text, make sure that I've assigned a few of those, just to convince you. Now we can prove it, again, using limits and so forth. Okay? So I want you to know it before we prove it. I want you to be convinced before we prove that what you're convinced of was worth being convinced of, okay? Okay, so anyhow, here we got it. So your discriminant is this, and you get -1. So it's a saddle point, okay? The function is level in the x direction, so the x-axis is part of the graph. If y equals 0, f of xy is 0, and similarly here. So the graph is on the axes, okay? In the first quadrant, or third quadrant, xy is positive, right? So when you do xy, like along the line y equals x, you get either x squared or y squared, either one, so it's concave up. In the second and fourth quadrants, x and y have opposite signs, so you have a negative x squared or a negative y squared out of this along the line y equals negative x. So it's level here, up here, down here. And you can relate that to the picture you just looked at. If you just take a paraboloid, not a paraboloid, a hyperboloid, does this in the x and this in the y direction, and rotate it this way, you've got it. This is just a rotated hyperboloid x squared minus y squared, okay? So it's kind of like this, rotated 45 degrees. And you can, I want you to think about that. Here, just go back to this, take a note. I see you're taking a lot of notes. And ponder this. It's not deep, but it's a little deep, okay? But it's not hard. And I think you'll get it, okay? So that's the procedure. That's all there is to it. Now, where's that picture you had? Let's do that one.